Yeah, so I think we can start now. Welcome everyone to this live session of 2-week refresher course in computer science on next generation technologies is sponsored by Ministry of Education. We have our keynote speaker, Arpit Joshipura. Arpit is General Manager, Networking and Edge at LinuxFoundation. Arpit is an executive leader and open source software evangelist across carriers, cloud and enterprise IT, spanning networking, orchestration, operating systems, security, AI, edge, hardware, and silicon. He was recently voted among the top 5 movers and shakers in the telecom industry. At the LinuxFoundation, Arpit leads open source networking, orchestration, and edge IoT, including LF networking projects, ONAP, Anuket, ODL, FIDO, OVS, DPDK, Open vSwitch, Acrino, Edge, IoT, etc., as well as major industry disruptions, including VNFs to CNFs, 5G, AI, etc. Arpit brings 30 years of networking experience, expertise, and vision to the LinuxFoundation with both technical depth and business breadth. He has orchestrated and led major industry disruptions across enterprises, carriers, and cloud architectures, including IP, broadband, optical, mobile routing, switching, layer 4 to 7, cloud disaggregation, SDN, NFV, and open networking, and has been an early evangelist for open source. Arpit has served in CMO, VP, and engineering roles within both startups and larger enterprises. So, Arpit, welcome to you, and good evening to you as well. You're joining from
yeah
yeah, over to you.
Okay, good morning everybody, and thank you for having me. And I'm excited to join virtually, and I believe we will have plenty of times for question and answers. So feel free to throw the question in the chat while I speak. What I'm going to do, and I'm going to share the slides right here. Can you see it?
Yeah, we can see it. Yeah.
Okay, perfect. So I was asked to cover networking and edge, and then my colleague after me would be Tina, who will cover details of edge blueprints and examples of use cases. But again, networking is very wide and very vast, and then open source is even wider. So I think what we have to do is break it down and kind of walk you through a few of these disruptions that have just happened. Now, let me start off by saying that I think you've heard from my colleagues, Brian and Priyanka and others on LinuxFoundation. So I'll go very quickly onto that. Talk about the open source journey in networking, and then talk about how things have gone into production deployments. And then we'll talk about some of the open source projects coming together. Okay. If you think open source, the next name that should come to mind is the LinuxFoundation. That's synonymous, right? And our goal is very simple. We share the greatest technology investment and build it for the open world, right? So that everybody can collaborate. And we are a nonprofit. I think you have heard about that. What's more interesting is we host these projects, and there's a lot of projects, right? There's almost 800, 900 projects that we host. Just because you can throw code on GitHub doesn't mean that we will host it. That's not, I mean, there are millions of projects on GitHub. We are only interested in hosting projects that need a community behind it, that disrupt, the markets, they disrupt technology. And they are the most important projects that are there in the world. And so there's about 600-700, and I'll talk about that in a bit. So we host projects. Projects become products. Once open source software is created, they are taken into deployments. They move into money-making business, everybody, and then it gets invested back, and everything is good to go. So that's the cycle for LinuxFoundation. But at the heart are projects. you might have seen this slide from my colleagues, but we're much more than Linux. Linux is pretty much everywhere in the world. But we have, in the last 20 years, expanded between, security, networking, which we'll talk about today, cloud, you've heard about that already, automotive, blockchain, edge IoT, I'll cover that today, web, AI, film, et cetera, et cetera. So a whole bunch of projects in multiple areas. Now, these areas could be either technology disruption or market disruption, okay? The thing that we need to understand is, we are nonprofit, but we have membership. So members basically run the foundations, and they influence the roadmaps. And most of the universities, governments, etc., are nonprofit, so our associate members, obviously no charge. But as these members influence and as they contribute through developers, you can see the type of changes that happen. 31 million lines of code added weekly, right? 20 million lines removed. 1.1 million pull requests, right? 10K repositories scanned, right? It's just the scale of operations at a global level is way more than any individual company or country combined. And that's why the power of open source is making LF a critical part of modern technology. Okay, so I know this whole session is intended at understanding how open source can be utilized and enabled, but it is important to know why open source has become such a phenomenon. And if you need to know the major industries, I would suggest downloading this white paper from the LinuxFoundation site. It's fairly recent, and we published this white paper to what I call open sourceification. 100-plus-year-old industries, telecom, automotive, motion pictures, banks, public health, energy, they all were completely proprietary for the last 100-plus years. And in just the last 5 to 7 years, they have gone through a radical transformation of becoming completely open source enabled. So please download this white paper. It's really good reading. All right, so with that background, I'm going to jump into networking, telecom, enterprise networking, cloud networking, and then obviously cover the edge as well. And for those of you who are in this space, you're quite familiar with this, but for those of you who are not, I want to emphasize the following, which is 20 years ago, servers went through this virtualization technology, right? Where every workload or every application did not have to reside on a separate server. You could virtualize it, and there came VMware. That same concept came into the network through something called NFV. And early days of OPNFV was the project where you started working on the virtualized pieces of networking software. Then came disaggregation, where you can actually buy hardware and software from separate vendors. And the power of that was hardware became commodity and cheap, and software was software defined, right? So the control plane, data plane separation, as we always called it, huge revolution. That was the start of Open Daylight and some of the early networking projects. Since then, the layers of software moved up the stack into automation. We're at the cloud native era right now, where Kubernetes is the underlying infrastructure layer. And as we move forward in the next 5 years, most of the networking will be edge and intent-based, enabled by AI and open collaboration. And the boundaries between an enterprise network, a carrier network, or a public cloud network will diminish. As you saw from last week's Mobile World Congress announcements, AT&T and Microsoft partnering, Google and Microsoft partnering, et cetera, et cetera. So this is kind of the journey, and this is where telecom networking is heading. Now, the main problem that exists today, projects are well understood. People create code, code has gone into production. no issues. One of the main problems that exist is how do I integrate many open source projects, and which ones do I integrate? And when I integrate, do I integrate in an open community so that I can have open compliance, open verification, open interop, open testing? And when I have that, it becomes repeatable. So we have two initiatives going on in the Linux Foundation. One under Linux Foundation networking, which is called 5G Super Blueprints. It's a very exciting initiative. And the other one is under LFEdge, called Acrano, which has a set of blueprints. And Tina will cover that, but I'll give you a high-level view of those. But the goal of those is to accelerate the projects and products into production. We've done some early analysis, and it looks like we shave off about 6 to 9 months of interop testing. So take, for example, when 4G was deployed, a Geo or a Bharti or Airtel would go in and say, okay, I'm going to deploy a base station and a core from Cisco or Juniper or Ericsson or Nokia, or whatever. And then they would spend 3 months testing those products together. And then there would be bugs, and then those bugs would have to be rectified. And then eventually they would end up fixing them, and then they would put it under POC, and then finally under production. That whole cycle had been anywhere from 9 to 18 months. What this does is they all are built on the same frameworks and same open source code, so they are by default interoperable. And then on top of that, the blueprints test the APIs and everything. So it's very, very rapid innovation. All right. So once you have this concept at the bottom of this chart, which is super blueprints, you take all these projects that are relevant, and I'll show you all of those and where they fit in. The three markets that are really excited about it are the enterprise networking market, the service providers, and then the end users, including government. And the use cases for each of those are written here. You don't want to solve every use case, but the most relevant and important use case, like private networks, 5G or LTE, or like moving workloads across multi-clouds, like getting end-to-end visibility and monitoring, right? So if a Walmart or is connected to an AT&T, is connected to a Google, and this is a real scenario in the US here today, how do I get my workload visibility between, and how do I monitor between these three different hubs, right? That's kind of what the enterprise networking problem is. The service provider network problem is fairly straightforward. I need to deploy 5G end-to-end, and I need to get global connectivity up, multiple countries, cross-cloud VPNs all over. And then the end users, like enterprise and governments, they want to utilize this for 5G. They want to unify this experience. And we have the US government, or the DARPA, DoD, very active in our projects, LF networking and others, LFEdge, that require these blueprints to come together, right? Because all of the US is being enabled through the Innovation Act and through the new administration on 5G and IoT. And then we have seen governments in Africa, some in China as well, taking advantage of these blueprints. So that's kind of the plumbing layer, if you may. And then on top, the vertical markets are and this is in a linear order. So this is for the edge compute and IoT. So industrial manufacturing, most relevant to edge computing, then energy, commerce, home, automotive, fleet. This is how the participation is going on, and this is how the markets are adopting to edge computing. Doesn't mean healthcare and smart cities is not important, but there's a lot of government regulations and processes that need to go through. Okay. All right, so we take a deeper step here and look at how these projects enable these use cases, right? So it's fairly straightforward diagram, left to right. You have the enterprise and the user, mobile, residential, small, medium business, or large enterprise. You come in through what is called a user edge, and I'll get into the definition of edge in just a moment, either through a project called ORAN. This is the ORAN Alliance, Open RAN software. So I host the ORAN software at the Linux Foundation as well. And then you have either Home Edge, that's a Samsung contribution, which is part of LFEdge, or FLEdge, which is a very industrial IoT project. And we'll get to the use cases in a bit. But let's say the user edge comes into a service provider edge, which is where a Crano and a set of blueprints fit in. And then through the clouds, many of those, you get into the core of the network, which has a stack from infrastructure. You heard about Kubernetes, any data plane acceleration kits into control plane, the Open Daylight Tungsten Fabric, and then you get into management, self-driving networks, zero-touch networks. There's many names enabled by a project called ONAP, which is the largest of all. And then you get into the applications, VNFs, CNFs, and in this instance, you could probably say, hey, a mobile packet core is an application. And so we have a project called Magma that was recently moved into Linux Foundation by Facebook. And that is one of an important project for the blueprint as well. So you can see the end-to-end view of what these projects, where they fit in and how they can pull in the entire stack. Okay, so let's double click on Edge in a bit. The one thing I want everybody to remember is the definition of edge. And historically, everybody has kind of used terminology that is wrong. Okay, thin edge, thick edge, far edge, near edge, this edge, that edge. They're all relative terminologies, right? It depends on who you are and where you are from that perspective. So what we did at LFEdge and Linux Foundation Edge is a great umbrella to participate, is we published, every year we published a Wikipedia style project called State of the Edge. And there is a research report you should download, which is a white paper on LFEdge website as well, where the terminology has been standardized by the community, right? There was no analyst who was doing this terminology. So we just decided that let's just do it like a Wikipedia style. So let me explain the terminology and it will be very simple. So when someone says edge, right, there's only two types of edges. There is, at the bottom, there's a user edge, which is dedicated and operated. And then there's a service provider edge, which is shared and as a service. And typically the last mile separates it, but it's not a hard cut all the time. So the colors are blended. Now, the user edge itself has multiple incarnations. You can have a constrained device edge. So these could be microcontroller or embedded compute. They could be smart device edge. So these are IoT gateways on a server, semi-secure locations. Or you could have an on-prem data center edge, where you can actually have a couple of servers, multiple of these inside, but still everything in the control of a user dedicated to your enterprise. Okay, that's kind of the user edge. If you cross the last mile, on the right hand side you have access edge, and there are two implementations of that. There's an access edge under a base station, and this could be up to 6 servers, 2 to 6 servers, right, depending on the size, and then move up a notch into a smart central office or what's called aggregation hub. That's where the edge stops. After that, it's a regional data center, and then a centralized data center, right, like a Google or an Amazon or an Azure. So the thing that you have to understand is not all IoT is edge, but some of the IoT is edge compute. So typically applications that need less than 20 milliseconds of latency or get 20 milliseconds of latency is an edge application. So if a sensor that dumps data every week to an Amazon cloud, that's an IoT application. It's not an edge application. Okay, so keep that in mind. 20 milliseconds plus mobility plus bringing storage and compute close to your application. That's kind of what edge computing is. On the top of this chart, you see a number of projects that we host. There's about 10 projects, everything from infrastructure to applications. The two key ones are EdgeX Foundry and Acrano. And I won't go into all the details. You can look it up, but I'll talk about the use cases for each of these. The thing that's more interesting is what Acrano does. And Acrano has a whole set of blueprints. And after me, Tina will cover each of these blueprints in detail. So I won't go into all of it, but really excited about some of these, like cloud gaming, for example, or connected vehicle, or private 5G, or the most recent one, public cloud edge interface, right? What blueprints are they are declarative configurations where people can actually, replicate this in the open and utilize this and deploy it, right? It's a set of hardware, software, CI/CD, the whole thing. And this has gotten very, very popular, okay? But these are edge and IoT blueprints that Acrano, there's about 20 plus and more are coming on the way. And the dots just represent where these blueprints have been tested for. All right, so then if I go and look at the use cases that are enabled by each of these projects, ORAN is all about 5G. It's all about end-to-end network slicing. It's about white boxes and disaggregation. So if you're familiar with the ORAN architecture, ORAN Alliance architecture, the CU, the DU, the non-real-time RIC, the SMO, all of these terms that eventually allow for open source to go all the way into the RAN. If you look at Kubernetes, that's your infrastructure multi-cloud layer. If you look at Anuket, that's an excellent project because what it's doing in LF networking is it combines what used to be OPNFV and a telco initiative called CNTT, and it made it into Anuket. Anuket basically provides reference implementation for an OpenStack-based deployment and for a Kubernetes-based deployment, right? So it kind of has the entire implementation, and GSMA is our partner that defines these specs, and the implementation happens in open source. And then ONAP on top is all about 5G, network slicing, cross-cloud VPN, zero touch, closed loop automation, et cetera, et cetera. And then I talked about Magma, which was the wireless. If you look at the use cases on edge, everything from anomaly detection to DevOps at scale and on-prem to predictive maintenance for constrained devices, IIoT, right? Turbines, transformers, pumps, TensorFlows, et cetera. And then building automation, industrial process control, water, retail, et cetera. Lots of huge cases, right, that have been already deployed in the marketplace. All right, so that's kind of the first step, I would say, from a project perspective. I'm going to pause and see if there were any questions. Feel free to put questions in the chat. Definitely going to answer all, if not as many, just so that, I know this is an education session. So, feel free to put questions as they come along or, save it to the end as well. So the next section is about, so great, you have all these projects. Which ones do I use in what order and how do I get to a use case? And so LF networking, which is kind of one of the largest umbrella foundation projects under LinuxFoundation, from a size perspective, obviously CNCF, which hosts Kubernetes, is the largest. LF networking is the second largest. We are hosting what is called a Super 5G blueprint. And what it does is it takes multiple of these foundations, and whether it's networking, edge, Magma, CNCF, ORAN, and then it provides a step-by-step open interoperability and integration into these projects, right? There's a mailing list, calendar, et cetera, et cetera. So feel free to, look, just if you search LF networking 5G super blueprint, it'll take you there. Do join the mailing list, do join the meetings, because this is kind of one of the best examples of pulling these open source projects together. This particular view is provided by our friends at the US government, DARPA, through the LF networking initiative. And it's very interesting because what they're saying is, I'm going to utilize 5G for everything from public safety to defense to enterprise to my own connectivity. And I'm going to utilize these projects because we fundamentally believe that open source is more secure, because you can't put anything in there, right? So from a security perspective, I'm not going to go through all the security scans and the CVEs and the whole process of security that LinuxFoundation has. But in general, open source is more secure and it's faster to innovate. And so they are going to utilize the entire end-to-end stack based on open source. And these are some of the projects. Now, I don't host all the projects, some of them are outside my scope, but we are going to pull it in to a full end-to-end stack that can be utilized for various use cases. So what are how does it come together and what are we seeing here? So if you look at the phases, phase one is essentially, Kubernetes, ONAP, Anuket, Magma, coming together for fixed wireless, private 5G, multi-access, etc. Then you add network slicing, and then you add ORAN. I'll show this to you visually, and then you will kind of get a good understanding. So the first phase, Magma, again, remember, Magma is the open mobile packet core. You take Magma, you take ONAP, and you take Anuket, Kubernetes. Akraino already has a print called ICN that has integrated Magma with it. And then basically core, edge, and then bottom is the NFVI layer, which is proven already. There's plenty of implementations of NFVI. So you take this and you use emulators on the RAN side, right? The next phase, you start doing commercial G-Node B, right? We are still at the mercy of the top 3 to 4 players on the commercial G-Node B side, right? The Ericssons and the Nokias and the Samsungs of the world from a global perspective, and obviously Huawei and ZTE for China. And then in the phase 3, you add ORAN SC, or the software community, to it. Now, the good news is ONAP has already proven over-NAVN interfaces, right? So all the interfaces have already been tested in the current release of ONAP. So effectively what now happens is everything comes together. Now you can have these use cases. You can repeat this, and then vendors and system integrators can build on top. Universities can test on this, right? And this is all done as part of the open community. Okay, so from my perspective, our priority is that from an open source networking and edges to complete these stacks, speed up the backend interop process, and integrate this into vertical markets, right? Because everybody wants to utilize the power of networking, power of 5G, power of edge. Okay, so that's kind of the high level view. Now, what I'm going to very, very quickly flip through is some more background on the overall landscape. Since this is an educational session, I don't want to just limit it to LinuxFoundation, right? So if you are interested in networking, telecom, as well as edge, there are multiple foundations that are focused on this, right? So there's the LinuxFoundation that we talked about, obviously largest and the largest community. There's the Open Infrastructure Foundation, which hosts OpenStack. I think Jonathan's going to talk to you tomorrow. There's ONF, there's Eclipse Foundation, Apache, which is mostly around big data. And then there's a few others. In terms of standards, you have GSMA, ETSI, 3GPP, ORAN Alliance, TM Forum, MEF, NGM, and ITF, TIP, and OCP. Now, we at the LinuxFoundation, specifically networking and edge, my philosophy is if a standard exists, code it. If it does not exist, code it and then upstream it to the standard. So we have, for the past 4 years, established a very deep relationship with all of our standards organization, so that when you get to deployment, you don't have a mismatch of a standard and an open source, because there's a very high possibility that open source becomes a de facto standard. And then you don't want ETSI to catch up 5 years later, and then you don't have it drop, right? And then there's alliances, specifically on the edge side, right? Automotive edge computing or IIC, and we just signed a partnership with Digital Twin Consortium, etc. Okay. All right. So those are the stack. Now I'm showing things that I host. We partner with the rest of them that are not hosted, and then some examples, right? So with Etsy and ONAP as a network automation software, these specifications are actually implemented in the code, right? Same thing with GSMA and Anuket, or TM Forum specs, or MEF, all the northbound, or 3GPP, right? These are all specifications that have been written and implemented in open source. So that cycle is really, really fast. Okay. And then, of course, we work very closly with open source foundations within LF and outside to make the end-to-end stacks. And I'll particularly call out three here. One is CNCF. So in CNCF, there is Kubernetes, plus there is a set of networking technologies, including telecom user group, that we make sure that we pull in and integrate. We have LFAI, which is hosting Acumos. So Acumos is AI and data right now. The Acumos is a project which has sort of templates for telecom. We partner very closely with Hyperledger. So this is blockchain for telecom. There are 3 use cases that are used, that are implemented. We had announced it as part of Mobile World Congress a year or 2 ago with Hyperledger. And then, of course, OpenStack and some of the others. Okay. I'm going to send these slides out and you can have this, but each of these projects has the name, the link, the wiki, etc., the chairs. I won't go through all of them. FDIO is the data acceleration. So it's used by a set, it's sitting on top to make really fast path go. This project's inside called VPP for the technically minded. ONAP, as I said, the largest of all. This, again, just a little bit of history. This is now deployed at, and I'll talk about where it's deployed, but it started off with AT&T, and now it's kind of the global de facto standard. Okay. Open Daylight, one of the first earliest project on an SDN controller. Tungsten Fabric, another one of these controllers from Juniper. The difference is this is an overlay controller. And then we just incubated a project called XG Villa, which is platform as a service. So that separates that one out. And then I'm just going to walk you through some of the examples of ONAP, right? Because and this is getting way into details, but this 30 sub projects inside, right? The goal of ONAP is very simple. How do you get network automation in the world of 5G and IoT when you cannot have manual changes? The network has to run itself. It has to be zero touch. Anything happens in the network, there should be a control loop that allows changes to happen. That's what ONAP gives you, okay? And ONAP has obviously become cloud native now completely, with cloud native network functions being there. But let me walk you through some real world examples. AT&T, for the last 3 years, this has been in production, and it's been production including first net responders. So all the firefighters and cops and everybody, right? Like as they move into territory which needs network connectivity changes, they used network automation based on ONAP, right? So very active. The chair of ONAP is from AT&T. China Mobile, fully implemented in one of their largest provinces deployment. Orange, last week, they publicly announced that ONAP is now in production. Huge journey by them. China Telecom production. Verizon, they're going to go into production later this year. Bell has been in production since Bell Canada in 2019. Deutsche Telekom, just at Mobile World Congress, announced that they have gone into production as well through their trial. Geo was an early contributor and a big supporter of ONAP. I think what they have done now is they've taken the basis of ONAP and then built on top for the deployment in India, right? Very powerful. All right. so I'm going to skip some of these slides. You can look at them. So at the end, where do I start, right? You start through foundations, you start through projects, you start, going through training. So I would definitely encourage you to go to Linux Foundation training and sign up for as many courses as you like. There are lots of free courses available, including fundamentals of open source, DevOps process. There's a course if you're a network admin, how do you move from network admin to DevOps admin? Okay, so there's a lot of these, participate in blueprints. And all you have to do is get yourself a Linux Foundation identity and get into either LFEdge or LF networking wikis. And then you join sessions, you give talks, you submit code, it's fairly straightforward, right? Now, if you are a vendor or a service provider, we would love to have you join these organizations and foundations so that you can contribute and influence, but you don't have to join, right? Like to contribute. And then these are just some research reports and white papers you can download. Okay, that's pretty much the formal presentation, and I'm going to open it up for questions. We have about 20 minutes of questions, and I see a few of them.
Thanks, Arpit, for such a brief introduction of a lot of things. And I want to thank Linux Foundation Networking and Edge, because sometimes you always feel that there is a standard bodies, there's a open source code, means where to see. Like, for example, if you have RFCs, IETF means ITC, and then when you see code, that's a very different page. And now this is what you guys are busy filling this gap of academia and industry and open source. That's really cool. And I also want to thank, because interdisciplinary is really important. Like you said that Hyperledger, now blockchain is also part of that. And I remember we wrote one white paper with LFEdge and LFN. This is on Hyperledger. That's really interesting how you guys are willing to collaborate with other projects as well. So yeah, with this, I have some questions for you. Like this is from Park, that what blueprint should academic campuses start looking with for a small hybrid cloud use cases? So this is, I also want to add, like sometimes, in academia, if you have some blueprints where they can, if you have more automation, like, because the focus here is more on, optimization, research problems, not in implementation part. So if we can have something for like academic stuff, like as a blueprint, or if you want to recommend something that this blueprint is really helpful for academic people to install something or to use something.
Sure. So I think the answer to that will obviously depend on how wide you want to go, right? Most of the US research institutions, and they are all part of the US government funded project, DARPA projects, right? They are going to utilize the entire 5G super blueprint end to end, as I said, right? RAN to edge to access to core, all the way up to the Magma layer, right? So Magma, ONAP, Anuket, Akrano, ORAN, etc. Right? They're going to utilize that. So there's the underlying plumbing layer, and then they will build on top. They will build NLP. They'll build security. They'll build algorithms that kind of encrypt things, and very fancy, sophisticated PhD type work, right? But underlying is a real stack, right? That is glued together from an open source perspective. And then what they'll do is they'll submit those changes back into the upstream community, right? So if, for example, the use case is network slicing, right? And ONAP supports network slicing, Magma will support network slicing, and then RAN network slicing. And now you have an end-to-end slice. And USC, for example, here in LA, is doing research on secure network slicing, right? So now how do I encrypt that? Now, that research has to run on a real slice. You can't just have simulators for that. So they're going to utilize that, test it on the blueprint, and then they will submit that back into the upstream code so that ONAP in general becomes much more secure when they do slice for all the world, right? That's how the process works. So the reason I gave you this example is depending on your use case, right? You can start participating in the community, and then you can, you will find very quickly by asking or whatever, that this is a good set of projects that I need to pull in, right? If you don't need a real RAN, you can just do emulators. If you don't need, or don't need a full 5G open core, you can buy it from someone, right? Like you may have an emulator there, right? If you're testing just the edge, just do a Crana, right? And just do blueprints there. So I think it depends. It's just, this is where I think we typically, once you join and participate in communities, you realize what is there and what you can use and all that.
Yeah, thanks. Arpit, and another question is from Prakash. Anuket, Kubernetes, can you talk more about it? Or Prakash?
Yeah. No, I think I understand the question. See if I can, I'll answer it.
Sure.
So Anuket, if you remember, as I said, is a project under LF networking that combined two projects, OPNFV and what was called CNTT. It was a task force work hosted by GSMA. So what they have done is they have defined something called RI1 and RI2. RA1, RA2, right? So reference architecture 1, reference architecture 2. Reference architecture 1 is based on OpenStack, and reference architecture 2 is based on Kubernetes. And then for that reference architecture, what Anuket is doing is it's implementing the RI2, which is implementation of that reference architecture. And so that's what the blueprint is going to integrate, right? Which is how does a Kubernetes software, what loads, what modules, what APIs, things like that, defined by the RA2 spec from GSMA. How do you code it, implement it, and test it? That's what Anuket Kubernetes is. Prakash, does that answer your question?
Yeah, it does. So are we thinking that RA1, RA2 are independent, RI1, RI2 are independent? There is no way that somebody will want both?
No. So
and together,
by default, all the carriers are going hybrid. Okay. There is not a single carrier who is just going to be cloud native. People may market that, let's face it, but the first implementation is always going to be hybrid. So there'll be VNFs and CNFs, and there'll be OpenStack in majority of the instances, but moving away from OpenStack into Kubernetes. So the new deployments will be Kubernetes on bare metal, right? So the reason they've separated the two architectures is some people only want to test and build OpenStack based for now, and then new deployments, right, in new POPs might be Kubernetes only based. So you want to keep the two separate, but the testing is a hybrid, both.
And the hybrid means in terms of VNF, CNFs only, or in the cloud perspective as well?
Both, because multi-cloud, intercloud is available in most of the OpenStack, most of the ONAP modules as well, right? So when you have automation like that, Kubernetes also has a layer. Now, keep in mind, the difference on multi-cloud and intercloud, it varies because Google has their version of Anthos, right? Azure does their thing. Amazon does their thing, right? IBM and others will do their thing. So public cloud players themselves will allow you to interoperate, but they're not all the same way. So just keep that in mind. But it's all multi-cloud, yes.
So that is the actual thinking is that going forward, if container is going to be the primary as we migrate, and even we are thinking, like example, I think Parth was looking at cloud native OpenStack. Okay, there is something called KubeOpenStack. They are looking at it. So we were thinking that can we contribute to part 2, which is the RI2, you have RI1, RI2, maybe we have something RI1 plus 2 kind
I
of thing.
think, yeah, so you should definitely take a look at it and look at what the telcos are doing there. And I think there are definitely there are challenges on the hybrid layer. And here are the challenges, right? Because at the end of the day, you don't want to go, bare metal on OpenStack or bare metal on Kubernetes on OpenStack with Kata containers and this and that. Like there's too many layers and too many flavors, right? And I didn't have that architecture diagram here. I can show it if you want, but in a CNF world, you need, and there's ways around, you can use OpenStack with that option, or you can just do KubeVirt or Kubelet or things that are much more lightweight, right? Because in a container world, you don't. The good news is the networking constructs are not embedded in the cloud layer, right? That's the fundamental difference. It's not OpenStack versus Kubernetes. But what OpenStack did was it had Neutron and concepts like that embedded inside. And Kubernetes kept the two layers separate, right? So that's why it allows a more lightweight container-based approach. So there's fundamentally inherently architecture differences, right?
Yeah,
Okay.
and
I'm with you.
yeah, I want to I get confused with the multi-cloud because you said hybrid cloud, multi-cloud, and inter-cloud. So if you can differentiate it a little bit. So
Yeah.
inter-cloud is the new one for me. So
okay. So inter-cloud, let's start. That's the easiest to understand. So there is between clouds, like there could, so let's take Vodafone, right? Or any of these large carriers. They all have deployments in different countries, okay? Each of these countries could have their own data center, but it's still their own, right? So that's kind of what I would start off with, what is called cross-cloud VPN, right? It's their own cloud, but across countries, right? Which allow for a homogeneous view and a homogeneous automation and orchestration, right? Now, in that same context, a hybrid cloud or allows deployments on-prem into an enterprise, right? So, for example, I'm a automobile manufacturer, and I have a company, I have a factory in India and in US, right? And I'm serviced by a Vodafone or a Deutsche Telekom or whatever, right? That is global or has relationship with global carriers, right? That needs to work also, the automation, the orchestration, the logs, the events, and all that, right? So those are the two easy to understand. Then you get into cloud, where you have between an edge and a core, right? You have APIs. And that's where the blueprints that Akraino came out with, public cloud edge interface API, right? So, because there's no standard there, okay? It's just the code that's going to be the standard, right? So that's kind of that. And then I think multi-cloud is just a generic term to make sure that if it's Amazon and Azure or this or that, right? Like you operate, right? That's kind of just a basic term. All right. Other questions?
Yeah. So we have one more. Akraino ICN blueprint has Magma. So I think the question is.
No, that is true. Akraino ICN. So there's an ICN blueprint, and Tina will cover it right next. It has Magma integrated with in an open source already. So that blueprint is already available. Okay.
And I have one more question, and this is regarding sometimes, Arpit, it's really hard for academicians or governments to look into these projects in terms of wideness. It is like from you have like 10 or 20 projects, like which suits me better or not, or which is good for me. If you can refer some sources which can be like a exec where we can look, is it a wiki we can look at into, or or
all
you
of
recommend
these,
something?
yeah. So I would say there are, I think it was in my slide, but lfnetworking.org, sorry, LF Networking and LFEdge have their own wikis, right? And the best source to just get an overview is there will always be documentation and white paper that define every project, and they say how much and all that, right? Now, if you're looking for community momentum, each of these projects have something called LF Insights. So that's a tool that shows the developer velocity and which companies are contributing. It's called LFX Insights, right? So you just go there and search for ONAP, for example, and you will see who is kind of contributing, participating, which companies, including the engineers there, right? So those two are your sources, right? The wikis and of course, there's a website, right, for the simpler version of it. But then you want to get into the source code and source documentation, it's all the wikis.
Thanks for info. I think
Yeah.
we will take some questions from discussion forum as well. We will upload this on our OpenEdX platform as well. And if we have some more questions, we can bring you directly as well.
Yes, absolutely.
Thanks. Yeah,
So
Prakash,
Prakash here, I have one question. See, let's look from the point of view of Indian education system, healthcare system, and government. And suppose we want to have a campus-wide network. When I say campus-wide, means all the researchers in all the campuses want to work together, and they can do cross tenancy in the sense that few of the researchers who are in, say, IIT Madras can deal with IIT Bombay, Delhi, or something like Delhi University, Ramanujan College. So now, because a project like example Shakti, let's say we are doing on RISC-V, we need to come with people from all over the places. So the question which Parth asked was blueprint, and that was blueprint for maybe for one campus. Now you have the one which you showed blueprint for the entire US. So can we similarly work with you to get an entire blueprint for India for specific to start with, let's say, campus network, and then maybe
Yes.
healthcare network?
Yes.
I think that will be a very good exercise for us to learn and bring something very valuable from everybody. Yeah.
Okay. So I'll just say the answer is yes, but do not assume that the blueprints are for a country, right? This is the difference, right? This is the geopolitical aspect of open source is completely eliminated in software, right? There is no such thing as a blueprint for India or you like I just gave an example of US government. They're using it, but China is contributing, Germany's like global developers are contributing, right? So effectively, and I think one of your next questions is exactly aiming at that, which is if I'm a downstream user called IIT or Government of India or healthcare or whatever, right? Like an end user community, how do I take advantage of upstream, which is the open source community, and influence that through neutral governance and neutral processes, right? So it doesn't have to be India, because what you don't want to do is you don't want to set up a VPN and a private repo of just the 5 IITs and ISC coming together with a few of the government, because now you're in the old way of doing things, right? It's a closed network. What you want to do is you want to go upstream, pick the project, influence the project, and then pull it down so that it is open. It's not forked. It is not closed, right? Because then you're fundamentally what you're doing then is you are bringing the global innovation versus just Indian innovation, right? You see the difference?
Yeah, I see the difference. That is why I've asked you the earlier question: how do downstream users like CSPs, telco providers? If I am AT&T, I use the, let's say, Acrino as well as Airship and all that downstream. But what we put on called network cloud in the what they call as one of the catalogs, I really can't use that fully because a lot of things they do inside is never coming out. And
no,
so
you don't need to.
what do
You
I
should
do?
not. No, because what
How?
they do, no, what they do is they used to do that, right? Which is they used to have code in network cloud that was different from what was in ONAP or Azure, right? Now, in the last 2 years, AT&T has adopted this upstream first policy. So if they need to change a catalog or they need to change something that is in open source, and 90% of the code now is in open source, right? The only thing that's not in open source is AT&T specific catalog items, right? Their pricing, their keys, etc., etc. So now what they do is they put, if they want to change the code, they will change it in open source ONAP and then pull it down. They have a CI/CD every 2 weeks, right? That goes in and integrates. So there is no more fork. They get the benefit of the global community, and they only have to add the 10% of their AT&T specific things.
Yeah, the devils are in the details. Devils are in the details, and the same thing used to happen with the China Mobile,
Sorry,
China Unicom,
you.
China Telecom, and yeah.
And
So
I think
yeah,
we're running out
We are
of time.
running
Right?
out of time. Yeah, we can take these questions later. Yeah. Prakash, so on this behalf of the organizing team, Open Technology Foundation and Teaching Learning Center, Ramanujan College, University of Delhi, we extend our heartfelt thanks to you, Arpit, for taking out time and interacting with our participants.
Thank you.
We really hope to have more engagements with you in future. Thank you so much, Arpit.
Thank you. And I'm just, as a closing, please join LF Networking, LFEdge, right? You can go into the wikis, sign up for the ID, right? Like you have to participate to take advantage. You can't just take advantage because you will never know otherwise.
Yeah. Thanks,
right.
Arpit.
Thank
sure.
you. Okay, bye-bye.
Bye.
So moving next, now we have, I want to welcome Tina. Tina is a technical executive leader, TSC co-chair, Ejecrino, ARM Foundation, Palo Alto, California, United States. Tina is an enterprise architect at ARM and co-chair of the technical steering committee for the Ecrino Edge stack. She has been keynote speaker in several LF, LFN, LFEdge events and got her Silicon Valley Engineering Award for Hall of Fame. With 60 plus patents, 36 papers, she led Huawei for 16 years before joining Philips, and now with ARM for last 5 years. Her sincere efforts has helped LF to build bridges across the globe, and we certainly want her to be part of India too. She is a guru herself and develops courses for LF and India's faculty development program. Is honored to have her deliver the keynote at PMMNTT 2021. Thanks, Tina, for joining us today. Over to you. Yeah, Tina, you are mute. Can you unmute yourself, please?
Tina, can you unmute yourself?
Yeah, can you try now? Yeah, can you try now? Because maybe
now, now it works. It was disabled. Okay, let me share my screen. You can see my screen, right?
Yeah.
Click the display mode. You can see the display mode.
Yeah, it's working.
Okay, cool. Hello, everyone. This is Tina Zhou. And today I'm very happy to be here to share with you all my understanding, experience, lessons with the Ecrino. Thank you for Arpit has already introduced about LFN and LFEdge. Ecrino is one of the LFEdge projects. Myself as TSC chair, yes, I have been co-chair for 2 years. Now I have been chair for 1 year. The new election will be in August. Well, we hope more people to stand up to say, hey, I want to be the TSC chair or I want to be TSC members. Okay. All right. Let's move. It says my screen sharing is paused.
Can you check it?
Yeah. How about now?
Yeah, it's working.
Okay, cool. So today's topic, I'm going to talk about the LFEdge overview, momentum, and news relevant to Equino from the Equino point of view, and also the Equino background and R4 summary and R5 forecast. R4 was announced in February 25th, and R5, our target date is August 25th. So I will also talk about the details of R4 blueprints and use cases and some commercial ecosystem adoption details. Okay. So here is the overview. Let's see myself. Okay. And momentum LFEdge. So as Arpit said, the unified edge framework is the foundation of the LFEdge. You can see all the way from the user edge, including the smart device edge, we have blueprint, and we have a blueprint across all the different kinds of edge, from user edge to service provider edge, from dedicated to shared, from operated to IaaS, PaaS, and SaaS. Yeah. And this about all the LFEdge projects. You can see there's a long line for Equino. It covers all the way from here to here. And Equino is at the stage 3, which is impact project. So all the other blueprint, all the other projects like LFEdge, Fledge, Eve, they have corresponding integrated blueprint in Equino. And also, we try to work with HomeEdge and SDO, and Beto is going to propose a new blueprint this month. And we have several blueprint like KNI trying to integrate the Open Horizon. From the end-to-end context point of view, this is a deployment-ready open source use cases. You can see here, we have to put Equino here together with like LinuxFoundation, ONAP. It's more like a glue to do the integration, test it, validation, and ready for deployment. This is a more detailed explanation how this deployment ready is. You see, from the IoT, Equino has blueprint called the IoT Smart Device Edge, integrated Fledge and Eve here. And also the other IoT like ELET, Edge Lightweight IoT Gateway, and UCPE, integrated Edge Xfungi, like building the automation for water, smart city for retail. We have several blueprints like Cassini from Edge to from the infrastructure, from the edge to the infrastructure, and also like the out edge, the lightweight enterprise edge, all deal with these things. So telco edge blueprints, there are like many like radio edge cloud, network cloud, and vertical edge application blueprints like connected vehicle, AR, VR classroom, and the enterprise edge cloud automation blueprints like ICM, private LTE, 5G, and the KNI provider access edge and industry edge. And also we have anomaly detection and surveillance like the security monitoring blueprints. This is about the LFEdge summary. I believe Arpit has already introduced this. So Equino project is at stage 3, and also the 85% of the premium members, they are very active participating in Equino. And I know Wipro is from India. There are more other companies who are not the premium members, but they also located headquarters in India, like Arton, yeah, they participating in Equino. So I would introduce more the contribution developers from India or from the country India, and a lot of people work in the States that they are originally from India. LFEdge accelerating the community collaboration. You can see there were like 25 more new members increase. I believe Api has already showed this data to you. And there were like more than 30 Equino blueprints in development. Like most of them are either already in deployment or being deployed or has a business plan for deployment. So this has the very high growth curve you can see from here, unifying the edge framework and lifecycle management. Cool. Equino Release 4 was available since February 25th. We got enables the Kubernetes across multiple edge, integrates across ORAN, Magma, and more. There were 7 Equino R4 blueprints, which are new, and total 25 participants in Release 4, because this a lot of blueprints just enhancement. They were created half a year ago or 1 year, 2 years ago. So Equino is Kubernetes ready, and Kubernetes enable blueprints across 4 different edge segments like industry IoT, machine learning, telco, and public cloud. There are new and updated blueprints like also targeting machine learning, connected vehicles, telco edge, enterprise, AI, and more. So in this case, I'm going to show you in one picture how the R4 blueprint located in different segments of the end-to-end spectrum. So starting from the micromac, this is how the Finland government, they built the smartest 5G road. And from the micromac, the little box and the LiPo, it creates the software stack you download. You run on the little box and the LiPo. It can prevent the, for example, the collection of the reindeer, well, before Christmas. And also you can see, get forecast for the weather, like icy road, those things. For the IoT predictive maintenance, as I said, it's integration of Eve, also the Fletch. So it has the predictive maintenance, like if the temperature and the industry in the factory raise up above the certain degree, it will just inform and turn it off and do some actions. I think it's backed up by GCP, and also GA is their customer. And the IC type 1 is the little board, the small board. It can be plugging into any IoT gateways. The ADAT IoT gateway UCPE has been used in many other telcos, the tier 1 telcos globally, like the IoT gateway and UCPE. It just provided the software. Now the good thing is the different blueprints, they share something, like ADAT and the 5G Mac LFEdge Enterprise. They share the same Edge Gallery, which is the app store for edge computing, and also share most of the software framework and platform architecture. So the 5G Mac Cloud Gaming has been like, it's more like a B2B2C, like China Mobile, China Unicom, they give the B2B like a slice, like a Mac to Tencent. And Tencent use this slide to do the slice cloud gaming, HD video, or live streaming for their B2C customers. And also the telco appliance, like it's a blueprint family, include the radio edge cloud like RAC, and the AI Edge, security, autonomous vehicle, federated learning. AI Edge is a big blueprint family. Currently, there are 3 blueprints under it. I was talking about this. The security one has been deployed by Baidu. Autonomous vehicle has been also deployed by Baidu and the other companies. Federated learning is deployed by WeBank. And the ICN has 3 blueprints on the ICN blueprint family. One of them, Arpit mentioned, was private LTE 5G, the integrated Magma. And the ICN has the customers, has the field trial from Verizon and Reliance Geo. Here is the connected vehicle has been deployed in Tencent and Dongfeng Mobile Group. The IC Type 2 is more for edge server. Type 3 is for Android Cloud native application. Type 4 is AR VR, and Type 5 is SmartNIC. And recently, the PDU, the DPU and the infrastructure PU process unit. Network Cloud family has like around 7 blueprints underneath, like Tencent Fabric, Unicycle, OBS DPDK, those things, and the public cloud edge interface. And it has a lot of top operators like AT&T, Verizon, a third-party cloud provider like Equinix, and the top cloud providers like AWS, GCP, and Azure. Microsoft Azure all participate in this. They have already provided versions of for Azure, and this release 5 is working on the AWS and already had the version, and the next one is GCP. KubeEdge, this is a very good example how they integrated the KubeEdge from CNCF and have this ETC use case, which has deployment in the highway for the electronic toll collection. And the KNI provide the access edge, PAE, and industry edge. It's more like how to leverage, integrate the OpenShift. I think it's a very good software stack, widely used. So this is about Equino R4 blueprint. The blue ones are the new one compared to R1, R1, R2, R3. So the green one are already existing there, and R4 just do the enhancement. Even the enhancement is a lot of work. So for R4, I would like to highlight some of the contributions directly from India. I mean, the developers or deployers are located in India, like ALAT, IoT Gateway, UCPE. Every meeting I see a lot of companies are participating. I can only remember Huawei, but I know there were many other companies. I think that there is really good industry environment in India. I can name all the names of those startup companies or those companies, but if anyone you are on the call, just say your name here or type your name here. And for the 5G Mac Enterprise, yes, I know Huawei was there. And for the connected vehicle, I see Pasa Labs is a great contributor for this. And for the ICM private 5G, I see, oh, Wipro, I forgot Wipro's name. Wipro's there, and the other companies like Rebecca, and IEC Type 2, Type 5. Yes, the company, I think GoPaddle was there. They are all committers. And Network Cloud family, I see like maybe the other companies I see they work for with AT&T and Juniper. I just can't name all of them. For the future blueprint, that means Release 5 and beyond, we see more names, more companies from India. Besides Reliance Geo and Pasa Labs, Huawei, Rebecca, we have GoPaddle. They have recently have the mini Kubernetes integrated to IC Type 2, already merged code. And Core Edge, they're working on this Cassini smart city and software-defined camera. And Archon, they are working with the evolvement of Radio Edge Cloud, which is leveraging the ORAN and their solutions. So I'm really proud of the community from India. And also I will especially raise this Tammy COVID-19 Rural Edge. I think they are heroes. Those, I think, like 3 to 5 developers working for this blueprint, themselves working because COVID, they work in the rural area. This blueprint is to provide the connectivities and to provide the rural edge so we can fight with COVID-19. And those developers, some of them got COVID. I hope that they are recovering soon. And really, we work very hard, but we still cannot catch up the speed of the spread of COVID. I hope the situation got control and all our developers are back to normal, back to life, and we can continue make this really to the something more meaningful to the real life. Yeah. A big thank you to India community and developers. So I would like to dive into the next level of detail for the Equino, the new intelligent edge. So Equino delivering a full functional edge solutions. We have more than 30 blueprints and gain the community support. It's deployable edge solutions are now globally adopted in commercial solutions to address several edge use cases. Equino hosts the community lab in New Hampshire University and multiple user labs like in AWS, in Azure, in Tencent Cloud, in Intel, Huawei or Huawei Cloud, and Red Hat, many other user labs. They are all connected. As long as you can push the CD lock to Nexus 3, you're done. And Equino delivered full functional new blueprints. So in R3 to R4, we have like a 5G Mac, AI Edge, cloud gaming at the edge, and also created the framework for defining and standardize the API. Also, there were many tools you can automate the blueprint validations. Like today, we have done the great work to automate the VAS, Linux, and Kubi Hunter, which are the security scanning. So as Arpit said, he feels open source project is also very secure. It's because we have a very strict criteria for the scanning of your code from all perspective. And Equino community has participated in several industry outreach events like ONES and those like KubiCom. So we have our member companies bring the topics relevant to the blueprint or the future projects to those events. Okay, so this shows the robust community contribution there. So it's deployable and fully functional edge stack for use cases across IoT, telco 5G core and vRAN, like SD-WAN, carrier edge media processing. As I said, more than 40 companies are engaged across the globe. 80% or 85% today of LFEdge premium members are active in Equino. So this is more like the pie figure. You can see the commit percentage by organizations and line changed percentage by organizations. There were more like 242 unique contributors from 70 organizations. In the top 10 the orgs, you can see whether your companies are listed here. This is not the latest one. This is the 2024 year, where we can wait for, if we have the half a year data, we can share later. And we wait for the full year 2021, who is the winner, the champion of the contribution. And I talk about Equino blueprints a lot. And what is an Equino blueprint? It's more like how you make a car. You have the blueprint family, which like the car family, like a Jeep. And you have the GMC Denali, or you can have the Range Rover. They are all blueprints. They're the certain type of car. For this car, I have this use case, like the use case is for the timely COVID-19, and it's fully CI/CD. You have the Jenkins, you have the push the log to Nexus 3 server, and proven and tested by community. You have to go through the API, the certification, you have to go through the documentation, have to go through the security certification, and also has the community life cycle support, and which produce the production quality. And in this case, we have more than 30 blueprints which are deployable. Yeah. Then what's next in Equino for the second half of this year? The new blueprint, as I said, the rural edge for timely COVID-19, it's mainly designed for the rural area in India. And we hope our developers recover soon so we can continue the work to catch the release 5, to catch the release 5 target date. So we have also contributors from the US, from Amazon, and from AT&T. And I think very good, but our key developers, they are really located in India. The companies are not saying work back to the office yet. And the IoT area, there is a project Cassini, IoT and Infrastructure Edge, has the smart city and the software-defined camera, 2 use cases. And we're gonna align the public cloud edge interface with SDOs, like the MEF, LSO, and we're gonna talk in ETIMAC, and also the GSMA-OP. And rapidly assembled and tested. We're working with both the Archon team and also the old REC team, and also the Blue Vault team to try to see how to fulfill the requirements for ORAN. And also we already published API white papers, and we are defining the platform security architectures and apply them to the blueprints, and enhance the functionalities and automation of edge workload, which is cloud native, and improvement of the release process, CI/CD, and future further collaboration with the other LFEdge blueprints projects like Beto and the others. Cool. LFEdge, which bringing the edge initiative together. IoT, telco, cloud, and enterprise. So I'm gonna show you some of the details. It's not detail. It's just like a highlight of the blueprints. So PSET, this is one I really recommend you to join. You can just talk to the top telcos or the top hyperscalers. They were at a call weekly. They drew in the whiteboard. It's very entertaining and very excited discussion. So the purpose of this blueprint is to specify a set of open APIs and orchestration functionalities for enable the multi-domain interworking across the functional domains that provide edge capability applications and require collaboration between the mobile edge and the public cloud core and edge. So the 3PE means third-party edge app, and public cloud edge app, and public cloud core. So you can think about this could be the AWS Greengrass, or the this could be like Azure IoT Edge, and this could be like Equinix Tinkerbell, right? The use cases and applications include more like Enco. So this Enco is originally from ONAP, so we use it, integrated. So far, we deployed Azure IoT Edge Cloud Native PCE app and the Greengrass Core PCE app, and deployment of PSET Location API app, which is using the PSET Location API hum charts provided by Equino PSET Blueprint. For this one, it's based on the ETIMAC Location API spec. That's why we work with ETIMAC very well. And also simulated IoT client code for the end-to-end validation. This is for release 4. We have more, a lot of progress for release 5, and already developed one more blueprint under this family. So PSET has the same name as PSET blueprint family. There's another one called Federated NEC Cloud Platform, which is more using KubeEdge as a basis. Okay. Another new one from release 4 is, as I said, the predictive maintenance with a thermal imaging camera, vibration sensors, etc. They can use the IoT gateway here, could be like for Nextcom, either x86 based or ARM based, and you you run Eve as an operating system here, then you integrate a fledge in the container. The fledge is more like a data control, data management. So in this case, we can do the hazards monitoring, like people detection in a hazardous area. So you can see the features here. Eve OS, not only as the operating system, it can provide remote management, zero trust security, both from the physical and software layers. And besides that, the AI models, which I also want to highlight, has the real-time data capture and cleansing at the device edge. The other one is the AI Edge, Federated Machine Learning Application Edge. This is also new from the release 4. You can see it provides a federated learning platform that trains the machine learning algorithm across edge devices without sharing the data that make the models. So we have 2 summits every year, one in March, one in September. In the September one, WeBank colleagues, they show us very interesting. You can see somebody enter the warehouse. You can tell the goods goes in and out of the warehouse. You can calculate whether it matches the actual inventory. So you can tell whether somebody steal anything from the warehouse and whether this person is a bad guy, and we can catch him. So it used fate as the first unsupervised learning algorithm, the hetero k-means. And we also add the data split module and add the data statistic module and also add the PSI module for computing population stability index. So this is really an exciting platform they built, not only for WeBank for the finance case, also for the AIoT cases. This is the Kubi Edge services. As I said, they said they have been used for smart road, cold chain, logistics, smart buildings. I think the most famous, the first use cases deployment was the ETC in the highway. This is very promising. And you can see the Kubi Edge managed application has these features. They do the first release focus on the machine learning inference offloading use cases. And the machine learning offloading to the edge server, the cloud does training, the edge does inference, and the device collaborates. So it's more like compared to K3S, it's more has the whole architecture with cloud and edge. So this is KNI for industry edge. This is new because before they have the PAE, the provide access edge. This one, why it is new? It's used for the manufacturing. The features include managing the edge computing clusters. You can see the GitOps based application deployment with the Argo CD. You guys might probably familiar with that. They use the Kafka MQ strings and the mirror marker here, not the RabbitQ or RocketQ. The machine learning as a data scientist with a Jupyter notebook. So if you're familiar with the Red Hat the technologies, this is everything you know. So the use case is more like the machine inference based anomaly detection. So, but the other one is called PAE. It has been endorsed by the Open Air Interface. Yeah, we have a blog on that. The AI Edge, the autonomous vehicle. So this use case is about the autonomous vehicle valet parking. So, but for release 5, they are working on something like autonomous cargo from the, it's for the baggage in the airport. I think this is very practical, has the meaning of in our real life. And they use the auto as their upstream components. So you can see here is that it has the starting and testing the behavior planner, global planner, etc. So we also have very good relationship with the authorware. So I like this blueprint a lot. Just for disclaimer, this is autonomous driving. It's not self-driving. Uh, well, I know these days, especially this week, there was a big debate what autonomous, what self-driving is. Okay. The private LTE 5G ICN, I think this was shown in Arpit's presentation about the super 5G the 5G super blueprint. Yeah. So the purpose is to create an EPC 5G in a box to enable the enterprises and operators to deploy LTE 5G, and can be used for manufacturing, retail, farming, and mining. I think mining is really great. I've already seen some of the mining cases in China. This is amazing. The good thing is they use OSS, such like Free 5GC and Magma. And you can see here is the private LTE 5G, I think blueprint, Magma integration, MVP plan. They're all from before. You can, so we kind of discussed this earlier. You can see the first step, we installed the Kubernetes 1 and 2 here, and then install the ONAP and ENCO. Actually, ENCO is part of ONAP, yeah, but they probably use the ENCO Prime version from the ANA networks, and then I don't know, ANA networks is based on US or India, but I see a lot of Indian colleagues, and register the Kubernetes 2 with the ONAP and plus ENCO. Then we onboard the CNF 1 and 2 and VNF 1. So I see somebody asked the questions to RP earlier, and this is just give you an example how we use CNF, VNF all together, and create number 5, we create the network service with XNFs, could be CNF via VNF, and deploy the network service, any services you define, and register AWG with Magma Orchestrator here. You can see, and manually configure AWG and run the UE or Gnode B tests. So this is the whole Kubernetes plus OpenAIS with the CUT infra orchestration. And the plan details include the Magma AWG 5G early implementation available, such as a VM like VNF, and also the Magma orchestrator early implementation available as a container. So we call it CNF. Look at this picture, the CNF here, CNF on top of this VNF. Next one. And the private LTE 5G ICN team will orchestrate this two using ONAP. So that's why you see from here, ONAP will orchestrate CNF2 and CNF1 here. And the VNF1 is under the CNF1. Oops. And the UE Gnode B emulator will also be orchestrated as a CNF if available in a containerized form. Yeah, if you have the Docker image, it works. So there are some of the R5 details, the new blueprint. You can see this is what I talk about rural edge. So rural edge, the target industry is healthcare, education in rural remote areas. The same thing, they participate in the fighting COVID-19 organized by MIT. Yeah, the competition, they won the champion. That's why they brought the code and the integration deployment here to have this blueprint. So the purpose is to features include the machine learning, audio, video enhancement using GAN. So not only just the for the COVID healthcare and also for the education. For the telehealth and LMS on the edge, control plan on the cloud, You can see it's more like an app. It can run on any infrastructure. The first case they are thinking about is the Wi-Fi. But I don't know how much Wi-Fi is available in the rural edge, especially in India. If yes, that would be great. Otherwise, we can consider, like, you see, we can consider the other the connectivities here, like the media plan close to customer side, such as the Mac servers in telco central offices. They listed the four use cases here, but I think the most important so far is the second one, the telehealth, appointment scheduling, payment processing, and electronic health records. So only when this connectivity is provided, that you should be able to get any prescription from the doctors. If the rural area does no COVID vaccine, right, is available. Right? So now they use the Equino Kubi Edge and storage gateway and the video bridge and gateway as infrastructure layer. And the upper layers for this application layer is more like working with the Amazon colleagues there. This is about the smart city. So smart city, they are based in the field trial in China Unicom. The target industry include, the scope is wide, like autonomous driving and packet delivering, smart energy, like smart buildings, water and waste management, and public health and safety, emergency services, and smart buildings, smart retail, and logistics. However, for this release 5, they are focusing the AI use case, like the traffic management to reduce the congestion, monitor the vehicle violations. I think this so if you want to have your own new blueprint or you participate in blueprint, for the first release, I will recommend that you just run a very plain and minimum the stack and have a baby step and try to have the CI/CD. And then in the second release, you can start adding more features and improvement and enhancement. Yeah. And all the applications that can be managed remotely using the cloud native practices here. And I will also like to show you some existing R1, R2, R3, actually R4 blueprints. So this LFEdge has a lot of participants from India. I just can name all the company names. I know Kamanja, Gaurav, Srini, yeah, yeah, there are more. Um, so, and this it belongs to the 5G Max system, and LFEdge provides a complete ecosystem for enterprise application on the lightweight 5G telco edge. So it has the use cases like a robot, like how you put the water bottle in a retail store and there's camera face on it. It can do the analysis and data statistics for like what kind of brand of the water is sold very well, is most popular, and is anybody to take this water bottle like a theft in the store, and many other cases, and also the machine vision on the campus net. Yes, I think who was that? Pranash, probably you talk about the campus network issue, and this one I was going to comment. This one is the campus network use cases. It has the centralized the processing using the wireless camera, the real-time response for detection feedback, provide the shared GPUs, and it also use like the in the telco cloud. It has the Mac M, the manager, and also this part are all the telco edge. So I think they have been deploying this in several tier one operators and also the enterprise use end users. It's because for the 5G use cases, I think enterprise use cases are more critical here. This one is the 5G Mac system. I talk about the B2B2C. This is the case. And I mentioned they can have uh, the provide the two green one is the edge connector, edge gateway. It's open source by Tencent as a hyperscaler. And this purple one, the UPF serving gateway and the mobile network exposed capability, this was provided by either China Mobile or China Unicom. So from the 5G providers. So in this case, you can see the edge connected, the edge connected is deployed in the cloud to enable the traffic offloading, subscribe the edge slice, and implement the application lifecycle management. The edge gateway is deployed close to the 4G, 5G network to perform the traffic steering, the local DNS service, and the traffic management, etc. So the use cases beside the 3-1 I mentioned, it also has the small deployment targeting Mac in access sites and enterprise. And for the media deployment, it's targeting Mac in the central office. So it's quite providing the different sizes. Micro Mac, as I said, it's building the smartest 5G road in Finland. They use the K3S container. Also, it runs on the OpenSUSE on top of OpenSUSE. So the microservices like Mac 11, TensorFlow, or Ruby sensors are considered as microservices. The use cases besides the interesting one I mentioned, like the radio collection prevention, and the many provide the fixed installation as part of 5G and base station, enables the new services that leverage especially the low latency like AR/VR. So the LFEdge school education video security monitoring, I think the key highlight part is the OTE. OTE, the green parts, are the over the edge stack, open source by Baidu. They already contributed to Equino. And so this, they provide the whole IIS layer, which has the Kata containers, Docker, provide the GPU, and the pass part could be like any hyperscaler, they have their own pass running on top of it. And through the OTE web, it can serve for their own applications or the open source applications. This one runs very well, has a deployment in Changsha, Hangzhou, Shanghai, and Beijing, several big cities in the either in the school or the big factories. It supports both x86 and ARM, and also support Kubernetes native. This about the ARM enabled Android cloud applications. It has already passed the 2 releases. Now this is the third one. Release 3, it runs for the Mbox, which support single instance based on the Mbox. And for the release 4, it has been based on the Rawbox and has the more multiple instances. Also runs the container above the VM, has the GPU support from NVIDIA. And for release 5, they are going to use the NPL Ultra server, which has a lot of cores and supposed to have much higher performance here. Smartnic, for release 3, it has been provided OBS DPDK. And then for release 4, it has the CT-based OBS DPDK offload into the Smartnic to accelerate the network performance and saves the computing resource and provide security management. And also, this is more for the storage case for the hyperscalers like ByteDance. And also the part of the UPF and VPC functions, it's more interesting for like China Mobile and Facebook, like load balancing, forwarding, DPI, etc., offloaded into SmartNIC to enhance performance of UPF that will be deployed in carriers' edge cloud data centers. This is connected vehicle blueprint. It has been deployed with Dongfeng Group, and they have already provided us blogs about the deployment. If you go to LFEdge newsroom, you can see the blogs. And it provides the smarter navigation and reduce traffic violation and collaborative vehicles and infrastructure systems. We're going to have automotive area workshop in end of this month. Please stay tuned. And we'll have not only the connected vehicle blueprint, but also the IVIX and also the MAC-based stable topology for cellular networks. This is IEC, IC Type 4 AR/VR. Both the AR/VR blueprint and the connected vehicle blueprint, they use TAS as foundation, the PAS. ICE use IEC, and SAS use AR/VR applications. So there are three other blueprints like operation guidelines, sports live, and gaming are in progress. Now available is the virtual classroom. Simulates the virtual classroom, improves online education experience. I think the app was also open sourced. Oh, by the way, the CVB connected vehicle, they are also open sourcing their applications. So this AR/VR, the applications is open sourced by Cornell University. And for this one, I think for the virtual classroom, it's very useful, especially when we are in the COVID situation. Yeah, and besides using these two blueprints, we happen to have the certification of Tencent Cloud, and so the certification is about to ask end users or the application builders to run your apps on your Equino apps on the Tencent Cloud. So we give you the badges for the certification. Okay, this is about the ICN. ICN can be used for telco, for cloud, for enterprise, and for IoT. The use cases include the zero-touch provisioning, use the BPA, bare metal 3, Ironic, and bare metal providers, and libvirt providers like KVM. Also, the KubeD, the Kubernetes deploy is being containerized and enables nested Kubernetes. So the Kubernetes used to manage both on the cloud and above the cloud, like either bare metal provider or the Kubernetes inside the virtual machine. This one, alert for gateway and UCP blueprint. You can tell this is the original architecture. Now they are evolving to interact with Edge Gallery. This one I'm very proud is because they have been deployed in multiple tier 1 operators. This one is the network cloud and Tencent Fabric. The Tencent Fabric is a single SDN, how to say, single SDN. It was a controller, you know, Tencent Fabric. And the kernel DPDK as an IOV and the CNIs are all supported here. I think this is very close to what we have been doing as a networking companies. It offers advanced networking features supported by Tencent Fabric, like the service training, network policies, security, VRP, route, the RA, and the flow management, etc. PAE is in parallel to the industry edge I talked about earlier. It's all Kubernetes native infrastructure family. And so you can see from here, it leverages the best practice and tools from the Kubernetes community and supports both containerized and VM-based. That's why I think viewpoint is supported here. if I don't see it, oh yes, here you go. Support for VMs via Kubernetes Bird and containers on a common infrastructure. And also lightweight self-managing cluster based on the core OS and Kubernetes. We call it the OKD distro. This is about the rack. So rack integrate the rig from ORAN and does the automated CD pipeline testing for the full software stack. And we are now doing regional controller, which is a feature project. So if feature project is like this, if we have blueprints here and we integrate from upstream community, if something we want to do and we take the upstream first, we go to upstream, we ask, can you do this first? They say, oh, you can develop it by yourself and you don't need to do it at the upstream community. It belongs to the somewhere else. So we just do the development project, like the feature project in a kernel, like a regional controller, has been used by several blueprints for the zero-touch deployment of rack to edge sites. So this is about the unicycle with rover and SRIOV. And rover means just one server. It's part of the network cloud. So it supports telco-grade applications and a wide variety of VNFs. And at that time, it was L-ship 1.2 or 1.3. Now, since we have L-ship 2.0 recently, I hope it can be upgraded to integrate L-ship 2.0. This one is more like unicycle with OVS DPDK. Unicycle is a rack. It has more like 7 servers, like some of them for control, some of them are for the data plan. So it's based on the Dell servers to deploy the Kubernetes on the cloud and containerize the OpenStack platform over cloud using L-ship. SIBA is more for the the software-defined VOLT, if you're familiar with the XPOM access network. So I think it's being deployed in Atlanta and somewhere in Texas. The IoT and remote edge use case for the IC Type 2, and it supports both single node deployment and the 3-node deployments. It's automated in CI. This is a foundation of many other around 10 blueprints. They use IC Type 2 as a foundation for their edge servers. And it has been running SIBA on ARM use case and use the project like Calico as a main container networking solution, and PalmSync installation support and support SIBA charts. I think this is a great baseline on foundation blueprints. And thinking about the commercial ecosystem support, I just want to highlight with you to see the Parquet deployment, community contribution focus, and lab resource provided by China Mobile. Equinix is a third-party interconnected data center company leading the PSEC. And China Mobile, they use the Equinix blueprints. They build more than 100 edge trials in the nationwide field trials. And FutureWay has contributed to KubeEdge and ELAT. So Ana Networks, they have done great work for the private LTE 5G and also the PSET recently. And ARM contributed so many blueprints. It's because they are all based on the IEC Type 1 or Type 2, and also the ARM hardware and software ecosystem. And Baidu is mainly leading the AI Edge blueprint family, and they are a deployer here. So for Huawei, they build LFEdge and the ELAT. Intel builds and donate many servers and drove the ICM blueprint family and enabled the Equinix R3, R4 VPs. They listed a lot of them here. And Juniper mainly contributed to the Tencent Fabric and engage with the private LTE 5G. And Nokia produced the Micromac blueprint and also relevant to ORAN and network cloud blueprint family. NVIDIA supports the, as I said, the Android cloud, that one. So Tencent supported the deploys the AR/VR 5G Max Slice and the connected vehicle deployments. WeBank deployed the LFEdge for the federated machine learning, and Wipro participated in the KNI R2 and also the proof of concept for open air interface. So for the executive summary, Equino is an edge project targeting to address telco, cloud, enterprise, and industry IoT use cases. There are 4 missions for Equino to create end-to-end configuration for a particular edge use case, which is complete, tested, and production deployable, and also develop a project to support such end-to-end configurations, and work with a broader edge community to standardize the edge APIs and encourage vendors and other communities to validate edge applications and VNFs and CNFs on top of Equino blueprints. So our mission to highlight repeat is to unify the multiple sectors of edge, deliver tested and validated deployments, and create a framework for the industry to collaborate. And so we hope we can have this project to produce the products and have the profits for everyone in the industry and in the supply chain. So I'm just in time. I have 1 minute left. We started the 3 minute late. Is that all the questions? Oh my God. All right.
No, not all are questions. It's just notes.
Okay.
Only a couple of them are questions. So I think you can start. Vipin, go through the
Sure.
and just close
So
it. Okay.
How do you
I want to Prakash, let's take one question and then we can ask Tina over email and then we can answer some of them.
Okay.
So,
So I think
the question. Let me take one.
Yeah, I
question.
think parts. Take the parts question.
Okay, so Equino Blueprints uses both Airship and Starlink X projects. So what is the deciding factor when to use Airship and when to use Starlink X?
If you're, okay.
Distributed versus
Yes.
underlay, I think. Yeah.
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 Can I, here, okay. Oh, here we go. So let's get back to this figure. Okay. So we do have a Starlink X blueprint. It's not part of release 4. It was like a release 1 or 2. For if you're working, you want to use the network cloud family, and then you definitely use Airship 2.0. Okay. If you're using the Starlink X, it's more like it's more to the centralized data centers, and you use the Starlink X. I think they are, I wouldn't say they're not relevant at all. They're connected, but depends. I understand Starlink X is more for enterprise use cases, and the network cloud family for Airship 2.0 here, for this blueprint family, it's more for telcos, like for AT&T. So the main driver for this is AT&T, Ericsson, Juniper, yeah, those companies. Dell, yeah.
Yeah, so any other project that blueprints use, like Airship, O, Starlink X? Any other projects that you would like to point out for managing OpenStack? Yeah.
Oh, you mean any blueprints uses OpenStack?
Yes.
For
managing.
For managing OpenStack, any other projects that we see in Equino except Airship, Starlink, and O? Any other project that I may be missing? Like, I'm just asking in general.
Oh, yeah. I think KNI use the OpenStack, but I'm not sure they use Airship. And the Radio Edge Cloud, they didn't use the, originally the rack and CBA, they are part of Network Cloud family. They were separated as a telco appliances family because they didn't use the OpenStack. Yeah. So I feel like Network Cloud family, they have 7 blueprints. They are the most the consumer of L-ship in Equino.
Okay, so with this, thanks, Tina. We extend our heartfelt thanks to you, Tina, for taking out time and interacting with our participants. And we really hope to have more engagements with you in the near future. And thank you, Tina, for giving us time.
Thank you for having me.
Thanks, Tina. I appreciate staying late at night and delivering it to all the people.
Yeah. Now I couldn't fall into sleep. All right. Have a good one.
Bye. Thank you, everyone.